Hey peeps, welcome back to Project Anonymous, and in today's video,
we're going to set up and experiment with a new fiber laser sent to us by Monport.
So let's get to it. Thank you Monport for sending us this laser. We've worked with their CO2 laser before, but this is going to be a whole different realm of different settings and different capabilities.
Yeah, absolutely. It's a completely different process using a fiber laser versus a CO2 laser when it comes to setup of the machine, as well as getting all the parameters set up. And we're going to try to cover what we can to get started with a new fiber laser and try to show you through the process.
So let's go unbox it and assemble it.
Let's go. So they package it with some plastic crush protection for the corners, which is really nice. You can see this corner took a bit of a hit, but the box is not damaged. Luckily it was double boxed. You can see here, this gouge clean through this secondary box, but the foam underneath it doesn't seem to be damaged at all. So hopefully the laser's okay. Came with some sample material to test out the engraving. It's a lot bigger than I thought it was. So, of course, in the box came the machine itself, the laser head, and the arm mount, which is pretty sturdy metal, and of course some instructions here. Now, of course, these instructions are about the software that comes with it. It actually came with a little USB stick that has the software on it. It came with a power cord, a USB-B to USB-A cord to connect to our computer, a foot pedal, which I've seen is really cool if you wanted to put serial numbers on stuff. You could use the foot pedal to actuate the laser for different items. Came with some kind of grounding strap. I'm not really sure what this is for just yet. The manual focus arm adjuster thing. It's like a little wheel thing that you spin, but you have to attach it to the top of the arm. Some tools, some screws to secure the laser head to the arm and the laser arm to the machine. And it came with a lot of cool samples that we can test out. Little dog tags, a couple rings, and some dog tags, and some thick cardstock paper, and then some metal business cards, all anodized aluminum in different colors, which is kind of neat. Of course, our safety glasses. Also, the wavelength of this laser is going to be different than a diode laser or CO2 laser, so the glasses that come with these are supposed to be for the wavelength that you're operating on. It came with a cool little metal ruler and then some little blocks that you can secure to the top. So if you had a repeat project over and over again, you can put these up so that it's always where it needs to be. So the first thing we need to do is attach this lead screw, which is right here, and that's a 2mm hex key. Now we're going to attach the arm with 4 more hex keys. This is 4mm. Next thing we're going to do is put on the lead screw manual height adjuster here. So first thing we're going to use is this plastic washer, another washer, and a 3mm hex bolt. So now we're going to put the laser head on, and we're going to use these thumb screws that we're supposed to hand tighten. So now what we're going to do is set up this laser, which we have plugged in now, using some of the settings that it comes with. So very important, this disc not only comes with the software that you can use to run this machine, but it also comes with a configuration file that we can pull into LightBurn for this particular machine. So things will be kind of ready to go when you operate it. So we're going to go ahead and plug this in and see if we can get this to work. Now we're going to go ahead and pull up here, and you can see these are the lasers that we have already. And what we're going to do is we're going to hit Find My Laser, and we're going to have this scan for the laser that's now connected. Okay, so you can see it found our laser connected. We're going to go ahead and click on this and click Add Device. So this is where plugging in that little USB stick will come into handy, because the file that we need to import for this particular laser is within that drive. So we're going to go ahead and hit Import EasyCAD Config. So now that we're in our USB stick, which is right here, we're going to go into the software, and in the software 11 here, and we're going to go down to where it says plug. And then you're going to see these Mark CFG files, and what we want to do is we want to pick Mark CFG 7, and then we're going to hit open. Now, for some reason, it's saying it has an invalid core file, so it's not going to update some of our Galvo settings for more precise type engravings here. I'm not sure why that is for this particular case. If you have any idea, please leave us a comment, but we're going to go ahead and go with this because it does change some other things that it has. It just doesn't have this correction file for some reason. So we're going to hit next, and we're going to go ahead and rename it, and we're going to hit next and finish. So now we have our laser. All right, so now we're going to change to that particular laser we just set up. And you can see our work area has changed now. I have our ruler here set to inches. So it's just about 5 inches by 5 inches workspace. So now we're kind of set up. Some other things that we want to look at in our settings here. This is our device settings. Again, our core file wasn't found, so there's no updates here, but it does automatically select our X and Y axis. If we did not import that Mark CFG file, it kind of defaults to Galvo 1 as being the x-axis, and we found that it kind of came in reverse if we didn't import that. So by importing it, it kind of corrects itself so that things aren't going to engrave out reversed or upside down or whatnot. So that's all good there. It did update our workspace, and right here this says our max and min frequency is 20 by 300, but if we go to the Monport website, it actually says that this laser can do a minimum of 1 kilohertz to a maximum of 4,000 kilohertz. So we're going to go ahead and update that here. And then here you could see that it corrected the offset of the red pointer laser. So for here we're going to go ahead and click OK, and we're going to do a little test square. One more thing I do want to change is the speed here being millimeters per minute. These fiber lasers are very, very quick, so I actually want to change that to millimeters per second. And so now just a simple line, we can go ahead and frame this out. So you can see that this is the red laser pointer that was adjusted. The offset was adjusted by the software that we brought in. Otherwise it would default to 00 and it may be different. So really cool is we can change where this red pointer goes in software. We don't have to physically change anything, but we're going to make sure that it is actually lined up with our fiber laser, because this is a different source and it may be a little bit different. So again, we're just going to make sure that this is all configured right. When I put my thumb over it a little bit, you can see that it actually is lined up pretty well. So you want to make sure it's lined up in this y-axis. So basically the laser pointer is actually where the fiber laser is going to burn. And then you want to check in the other axis as well. So if we did need to adjust, like if that red pointer wasn't lined up with the burn, we can adjust that here in our X direction and our Y direction to get that really, really refined. We could go down, I think if we went to negative 1.8 millimeters in X direction and negative 0.8 in the Y direction, it would actually be perfect. So we're gonna go ahead and set that. So now that we know exactly where our laser is going to burn, now we can go ahead and do a material test. So to set up the material test, I'm going to go ahead and delete this. We're going to go into Laser Tools and Material Test. And what I actually want to test out here is power and frequency, because the frequency is what will change the color of materials. So we're going to go ahead and change one of our directions to frequency, and our min value we can put to 1, and our max value we can put 4,000 to see the full range here. And then I'm going to make it a little bit smaller because we're going to use one of the cards that came with the machine. 3. Let's frame this out to see if it's big enough. Okay, so now we've got that sized right. Now I'm going to adjust some things here. So edit material settings. We'll go ahead and do the crosshatch. Yeah, that looks about right for speed. So that actually looks pretty good. We're just going to leave that. And then our text settings, We want to make sure that we're going to get visible burning through there, so that all looks good as well. I'm actually going to turn up power a little bit because I'm not sure. We'll do a 60% and see what that looks like. I think we're ready for our materials test. So it's finished, and it looks like we have some pretty interesting results here. I'm not sure about the feasibility of going all the way to 4,000 kilohertz with this material, at least. So maybe it will have different results on steel or something like that. Some areas that didn't turn out so well. Again, that's part of the learning process and why you do a material test, so you kind of know what setting works best for that particular material. So we kind of know what works best for anodized aluminum here. So I guess what we could do is we can put our little Project Anonymous symbol over here using the best settings and let that finish up. Very clean results there.
So far, using their little test pieces, I found that I think it looks really high quality, but do you have any thoughts, Dad?
Yeah, the build quality of it is obviously what you would expect of a high-end laser. Monport did a really good job of getting the design stuff right to get this really nice finishing when it comes to how you put it together, the stuff that they include in the system, like the little foot pedal that we could use for future projects. So really the fit and finish looks really good with this laser. The output of the laser is also really, really high quality. So again, we're new to the fiber laser realm, and we have a lot of experimenting to do to figure out the right settings for different types of materials. So for this video, we just played with a little anodized aluminum or painted aluminum, and we've got some experimenting to do with stainless steel and all different kinds of metals, which I'm really excited to get into. But we are by no means experts at this yet. We're going to get to work and expect to see a lot more videos with this laser in it to come.
So stay tuned for those. And if you want to get one of these lasers for yourself or any other Monport lasers, use our discount code Anonymous10 for 10% off.
10% off, Anonymous10.
Anyways, thanks so much for watching. I hope you enjoyed this video. Please like if you liked it.
Like it.
Subscribe if you enjoy our content.
Subscribe.
And turn on those notifications to get reminded every single time we post a video. Stay crafty.
And be happy.
Bye.